Hi, my name is Zainab Al-Ramahi. I'm in grade 10 and I go to Lancaster High School. So my project, which is entitled MAR, Mobile Autonomous Robot, the device that detects flammable gases, is a project that I designed to counteract the flammable gas problem. Flammable gases pose a really big threat in our society, whether it be by powering your home or by an auto shop or in any situation, flammable gases are always a threat. So this project is important because a lot of people have died over flammable gases, and a lot of people can and are at risk for serious harm or even death by flammable gases. So it's important that there's a detection system in place that's efficient and can actually detect them so that people can be safe. This project focuses on three gases: carbon monoxide, LPG, and methane and butane. So for the hypothesis for the sensor, I hypothesized that overall, the sensor would detect all of the three gases, since the MQ9 sensor, which is what my project is based on, is meant to detect all flammable gases and the gases that are part of that. So the timing hypothesis was that all of the timing would be random because the robot is designed to move at incoherent and a non-pattern like movements. So there really was no timing, so that the robot could go all around the room and it's not really predictable. So the timing would be just random overall. So the overall hypothesis was that the parts and components would just work together to create a viable sensor. So for the materials and procedure, the project was kind of designed in three stages. The first one was actually building the sensor and its circuit. The second one was preparing the chassis, and then the third one was just putting them all together to create a mobile autonomous sensor. So for building the actual sensor, it was basically a circuit where you needed a breadboard and jumper wires and all the normal things you need for a circuit. And the MQ9 sensor actually had to be calibrated using a code. So once all of that was put together and the code was calibrated, the sensor portion was done. The second portion was the chassis. So it was essentially a vacuum cleaner that was taken apart, and its proximity sensors were used and its base were used as kind of a vehicle for the MQ9 sensor circuit. The final portion of the procedure was to take those two components and then put them together in one to create the device. For this project, three series of trials were done. The first one was carbon monoxide, the second one was butane and methane, and the third one was propane, or LPG. So carbon monoxide was done by leaving a car engine running so that the exhaust would produce carbon monoxide. The second one was butane and methane, and it was essentially done by a lighter. The propane, which was LPG, was done by simply leaving a propane tank open. So each test had A, B, C, except for butane and methane, which only had A. So trial A was done the sensor was initially placed 5 feet away from the source of the flammable gases. So carbon monoxide, which was the first trial, had 3 sub-trials, I guess, trial A, B, and C. Trial A was done when the sensor was initially placed 5 feet away from the source, which was the exhaust. Trial B was when the sensor was initially placed 10 feet away, and then trial C was done 15 feet away. Each test, A, B, and C, were done 3 times to ensure accuracy and validity, which was just to ensure that the sensor would actually detect the gases. The timing was really unpredictable, so it was more of focusing on the sensor's abilities to actually detect the gases. Butane and methane, which was the second gas, was done by placing the sensor 5 feet away. And because of the lighter and because it's so small, it was really inefficient to do any more distance. And then the third gas, which is propane, was done by placing the sensor 5, 10, and 15 feet away, similar to carbon monoxide. When talking about the results for trial A of carbon monoxide, we can see that the range was 19.6 seconds to 47.8 seconds, and the average time for detection was 29.6 seconds. When talking about trial B, which was when the sensor was initially placed 10 feet away from the source, the range was from 49.1 seconds to 103.4 seconds, and the average was 80.5 seconds. When talking about trial C, the detection time ranged from 122.2 seconds to 203.9 seconds, and the average time was 161.9 seconds. When talking about the results for methane and butane, when the sensor was initially placed 5 feet away, the range was from 17.4 seconds to 49.8 seconds, and the average time for detection overall was 32.8 seconds. When talking about the results for propane, the range was from 38.8 seconds to 97.8 seconds, and the average was exactly 1 minute, or 60 seconds. When talking about trial B, the range was 136.5 seconds to 204.7 seconds, and the average was 169.4 seconds for detection. When talking about trial C, the range was 126.1 seconds to 343.8 seconds, and the average was 255.1 seconds for detection. In conclusion, the sensor detected the gases 100% of the time. Like before, my hypothesis supported the conclusion in the sense that the time was random and there was no real pattern and coherence towards any of the motions of the robot. What I enjoyed about this project was getting out of the routine and learning something new, and especially learning more about circuitry, which is something I was always really interested in. The next steps for this project are very broad. For example, the sensor could be connected to some sort of app or mobile device that can actually tell you the data, and if it gets to a dangerous level, can inform authorities so that proper steps can be taken to avoid harm by these gases. Moreover, I think that a really great addition to the project would be building your own chassis so that the sensor could be more personalized and kind of in direction of what you want it to be. This project has many applications in the real world. This sensor could be used anywhere where risk of flammable gases is present. It can be used in the auto shop industry where the risk of flammable gases are high. It can be used in infrastructure projects, or it can simply be used in homes. Because this project is autonomous, it can be very efficient wherever it's necessary. Thank you.